Our next speaker, Paddy, a software engineer on the Terraform team, is here to talk to you about two tools, Terraform and Nomad. And I've been promised a live demo. So please take a moment to pray to the demo gods as I welcome Paddy on stage. Please give it up for Paddy.
Hello, everybody. Welcome to Going Multi-Cloud with Terraform and Nomad. My name, as Seth said, is Paddy. I'm a software engineer on the Terraform open source team. I work largely on the providers, which is, those 75-ish things that Mitchell mentioned earlier. I'm one of the people that helps develop and maintain those. We are a large team, so I can't take all the credit. We like to say at HashiCorp that we want to provision, secure, connect, and run any infrastructure for any application. That's kind of a tall order, so today we're only going to talk about the provision part and about the run part. We're also going to kind of focus on the any infrastructure part of that, and I guess we're kind of talking about the connect part a little bit too as we do it. We're talking about the any application part a little bit. So, okay, I guess we're talking about all of this today, except for Vault and Vagrant. Sorry, Vault. Vault does work excellent with what I'm going to be talking about today, and that's been mentioned a couple times. And Vagrant also helps with all of this. I just don't have time to talk today about all of them, and you've already heard from people who know much more about them than I do. Before we talk about all of that, though, we should really talk about why you would want to go multi-cloud in the first place. Because going multi-cloud, like operating in two different cloud providers' data centers makes your life more complicated. And I don't know about you, but I certainly didn't wake up this morning and be like, you know what? Let's make my life more complicated just for fun. Like, why not? What could go wrong? There are really two main benefits you get for going multi-cloud, and the first one is obviously resiliency. Sometimes, it's rare, but sometimes cloud providers do have bad days, and I like it when cloud providers' bad days don't turn into my bad days. So if my application can stay up even when one of the cloud providers I depend on does not stay up, that would be super swell. And that's something that going multi-cloud can help with. If you deploy your application across multiple clouds, you obviously need more than one of them to fail before your application goes down. The second main benefit is that you get cloud-specific features. As the cloud has become a little bit more commoditized, clouds have started to embrace having special and differentiating feature sets. But sometimes you want to use the features that are available from multiple clouds all at the same time in your application. So by embracing multiple clouds, you can use all of the specific features that each cloud has to offer. And you can do so in the best and most secure way possible from within their own data center. So with that aside, or with that taken care of, let's talk a little bit about Terraform. Terraform, as you know, is a tool that helps provision your infrastructure across multiple clouds using the same tooling. Now, we say this a lot. Sometimes people get confused and they're like, aha, I'm going to develop like a single config, and it's going to be like, here's what an instance is. And then I'm going to point that config and I'm going to say, deploy that to AWS and deploy that to GCP. That's not quite accurate. We haven't developed an abstraction on top of the idea of an instance. Because that kind of turns into a really leaky abstraction really quickly. So we've avoided doing that. But what you can do is you can use the same tooling to say, I want an AWS instance and I want a GCP instance, and you use the same tooling, the same workflow to define that. You can also use variables that are used and returned by those in the same config file, and I'll be demoing a little bit of that later. It sounds a little abstract and hard to explain right now. It gets much more clear when you see it in concrete terms. One of the nice things about Terraform is that it's declarative. And when I say Terraform's declarative, what I mean is you write a configuration file telling it what you want the state of the world to be. And Terraform then takes that configuration file, figures out what the state of the world is, and goes out and makes the changes necessary to make the state of the world match your configuration file. Terraform's also graph-based, and it seems weird to sell this as a selling point, but because it's graph-based, Terraform's able to know things like, hey, this instance needs a disk, so I need to stand the disk up before I stand the instance up. Which is useful and doesn't require you to say anything. You can tune these, but you don't need to. So because it's graph-based, Terraform's really quick to stand up your infrastructure. I'm going to stand up an entire infrastructure in front of you in a few minutes, and we're going to do it in only a couple minutes. So because Terraform is graph-based, it's able to operate all these things in parallel because it knows what the dependencies are. Terraform is also predictable. We work really hard at this. We have a Terraform Plan command that offers you the ability to see what is actually going to happen to your infrastructure before it happens. When you're changing your production infrastructure, it's really helpful to know what's going to happen and be extra double sure about that. So we work hard to make sure that what you see in Terraform Plan is what you actually get. And finally, most importantly for this talk, Terraform's API agnostic. As mentioned, we're approaching 75 providers. I checked like a week ago and we were at 70. And 75 does not sound like a bad guess to me as to where we're at right now. So we're API agnostic. What that means is the same workflows, the same tools, the same ideas map to all of these different API providers, and you can use them all in conjunction, and you can use them all in the same way. When you want to adopt a new provider, when you want to adopt a new service, you don't need to learn an entirely new set of tools, an entirely new workflow. You just continue on with Terraform. So with that out of the way, let's talk about Nomad. Nomad is a scheduler that will help you schedule and run your application across multiple data centers. Sounds useful. Like Terraform, Nomad is declarative. So you tell it what job you want run, and it figures out where to put it and kind of makes it happen. Make it so. Nomad is scalable. Over a year ago, we ran what we call the 1 million container challenge, and we scheduled 1 million Docker containers across 5,000 compute nodes in under 5 minutes. And since then, our performance has only improved. So Nomad isn't a toy. Nomad is something you can use in a large data center today in production. Nomad is also predictable. Like Terraform, it has a Nomad Plan command that tells you what it's going to do before it does it. So now you can make changes to your application at runtime with the same confidence you make changes to your application or to your infrastructure at build time. And finally, and again, most importantly to this talk, Nomad is infrastructure agnostic. So Nomad operates basically no matter what your data center is, whether it's a private cloud, whether it's AWS, whether it's GCP, Nomad can be deployed to any of them. Whether it's Oracle's cloud, whether any of these cloud providers you can deploy Nomad to, it doesn't care. Nomad also works with a large variety of task runners. So whether you're using a raw executable, whether you're using a Java jar file, whether you're using a Docker container, Nomad's able to run your application no matter how you're packaging it. So that's Nomad. So let's talk a little bit about what we're going to do today, because we've got a little bit high level here. So today what we're going to do is we're going to deploy 2 different clusters. We're going to deploy a cluster in Amazon Web Services, and we're going to deploy a cluster in Google Cloud Platform. In these clusters, we're going to have in each availability zone 1 Nomad server and 3 Nomad nodes. And then we're going to take these 2 clusters, we're going to connect them with a VPN and turn them into 1 cluster. So that's kind of the end reveal here, is we're getting to a single logical cluster deployed across both of these clouds. So with that in mind, let's go to the demo. I'm going to take careful aim at my foot here because I'm relying on the internet for a demo. So we'll see how this works out for me. As you can see, I'm in my terminal here. So I'm in my directory for my project here. And you can see I've got a whole bunch of files here. So what we're going to do is we're actually going to start this off with a Terraform plan here. And it's going to refresh the state for all of our stuff that we want to build to kind of update the state of the world as it is. And you're going to see that I've got 118 things to add. And you can see each of these things that we're adding here. You can see what the values are going to end up being. Some of them say computed. When it says computed, it just means I don't know yet. The API is going to tell me when it happens. I'm not going to go through all those right now. The main reason I'm showing you this is because I'm going to start the Terraform apply right now, because you don't want to sit here and watch it run for 5 minutes as we kind of just look at the screen and watch it go. So I've got Terraform apply running. What's happening right now is I've got AWS resources, GCP resources being created in parallel by Terraform. You can see I've got a bunch of them scrolling past here. It's basically standing up my entire infrastructure. Terraform largely excels at standing up the platform your application is going to run at. Think of it as like your hosts, your networking, your security groups, all of that fun stuff. Terraform really ends, though, when it comes time to I want to deploy my application. There are ways to do it. It works. And for some people, it may even be the best option for a smaller team or something like that. But once you get to multiple deploys a day of an application, it's really going to start feeling pain points. And that's really where we recommend handing off to a provisioner like Nomad. So basically what we're doing here is we're standing up a Terraform, we're using Terraform to stand up clusters that will run Nomad for us. So as that happens, I'm going to resize here. So far, the network seems to be working for me. So thank you all for your demo god prayers. So now, as that happens, I'm going to take you just through a quick tour through the Terraform files that we created that are standing up this application for us. So you'll see I've got some files here and a bunch of folders. Folders are what we call Terraform modules. Terraform modules are basically like functions. They accept input, they return output, and they encapsulate a set of behavior. But before we get into the actual Terraform infrastructure, we're going to look at Packer really quick. So I'm going to change into this Nomad image directory here. And you'll see that I've got an image.json file and 2 folders. The folders just have some JSON files in them and some HCL files in them, along with some systemd services. What Packer's doing for me is Packer's building the base image that I am deploying to Terraform. And this is going to be the basis of all of the servers we're running in production today. You can tell that I've got 2 different builders here for Google and AWS. I want images in both of them. And all it's really doing is copying in some files, just copying in some more files, and then running some commands, updating apt, installing console, installing Nomad, moving all of our files into the right places, and enabling Docker. So that's really all of our image is doing. And if we look at the files here, we can see that the files also don't have really anything special in them. So if we look at, you can also tell they are divided by cloud, and that's because we are taking advantage of the auto-joining behavior that has recently been released in console to automatically join our nodes together using the cloud provider information. So I've got some variables in here that you can tell based on the curly brackets. These aren't anything special for Packer. It ignores them. I'm going to come back to these in Terraform later to get us some definitions based on them. But basically, this just allows me to tie Terraform into the Packer build process. These files are defining basically, this AWS client.json is defining the config file for console. If I look at nomad server.hcl, that's just defining the server for our Nomad, or the config file for our Nomad server. Nothing special, nothing really out of the ordinary here except for those variables that Terraform is going to fill in for us. So that's our Packer image. And our Packer image, again, is just going to be the basis. It's what each of the machines that we're standing up is going to be using. So you can tell that I'm also using Terraform Providers here. I've got our AWS provider configured, and I've got our Google provider configured. Nothing special there. I'm reading credentials from a shared credentials file for Amazon, and I'm pulling credentials from the application default credentials for Google, basically just using the standard credentials on your machine. Not exactly recommended for production use. I would recommend something like Vault in that case, which also works. But just for demo purposes, that's enough to get us started. So, and you can see on the left side of my screen here, you can see that my Terraform apply has finished, and I have stood up 118 resources. So we'll take a look at those in a minute. But so in my Amazon file, I'm calling the AWS module. I'm providing some information to it, which AMI to use, which zones to use. And in my Google file, I'm calling the GCP module and providing some variables to it. I'm also passing in what the AWS servers are, and that's so I can bootstrap Nomad, and you'll see that in a minute. But that's a little bit of a cheat on my part, but I'm passing in that. So that's kind of where it all kicks off. This is my main module for Terraform, and I'm kicking off my accounts there. But in each of these modules, we define the infrastructure we need from each of these clouds. So if you look at GCP, you can tell I've got some interface. Interface is just where I'm defining my variables and where I'm defining the outputs that the module returns. This is, if we're thinking in the function example here, then the variables are going to be the arguments that go into the function, and the outputs are going to be the return arguments that come out of the function. So basically, I'm just defining some information here, which zones I want to run in, which region I'm running in, and I'm returning some of that information back out, along with some of the information about Terraform's output. So, but I'm also creating a Bastion host. So my Bastion host, because I don't want to allow everyone to SSH into all of my, there's no reason to SSH into a Nomad server from the outside world. So what my Bastion host does is it allows me a way to get into my private network without exposing all the machines on my private network to SSH. So my Bastion host basically just kind of gives me a foothold into my private network. So you can tell the configuration for this is very simple. I'm giving it a name, I'm telling it which machine type to use, giving it a disk, some network interface, I'm adding my SSH key to it, giving it a service account, and telling it to create but before destroy. So that's my instance template. And then Google uses instance groups. This is kind of like the equivalent of an Amazon auto scaling group, and it's basically just going to spin things up based on that instance template. And they're all going to spin up across all these zones. So that's my Bastion host, my nodes. Well, actually, let's talk about servers first. Servers, this is where it gets interesting. Servers, again, I'm just going to use another instance template. I want 3 of these, so I set count equals 3. This means Terraform is going to repeat this 3 separate times, and it's going to create 3 instances based on this configuration instead of just the one. It's going to give it a name, and it's going to tag it. The tagging is important, so I'm tagging this with console server. And that's how GCP nodes are going to find each other, because they're going to go to the GCP metadata to look up console server tags, and that's how console is going to bootstrap the cluster. We're setting up a disk, network interface, and then metadata. So in the metadata, I'm setting up a startup script. And what I'm doing is I'm grabbing the IP address using curl from the metadata server, and I am replacing all of those variables, just using sed, nothing fancy, in all of those files that I built into Packer. And why I'm doing this is because Packer has the application, or has the configuration files at build time, but it doesn't know anything about the server IPs. So when the server starts up, it knows all of that information, so it's injecting all of that. And Terraform knows some of that information, so it's also injecting some of that information. So by using it this way, I'm able to inject that information into a Packer build. After it fixes all of our config files, it enables and starts console and Nomad servers. Then it joins the WAN for console, and it does the Nomad server join as well. And then our instance group manager just spins up. We're going to have 3 instance group managers, 1 in each region, and they're each going to spin up 1 node for Google. So that's going to be our Nomad servers. And finally, let's talk about nodes. It's almost an identical setup. The only thing that's different is we're using the console client job instead of the console server job, and the Nomad client instead of Nomad server. And we're going to have 3 of these instances instead of just 1. So that's our GCP config. Let's look at AWS really quick, because AWS does some interesting stuff. Again, we've got a Bastion file. This is, again, the same thing. I'm just using a launch configuration in an auto-scaling group here instead of an instance template and an instance group manager. Largely the same concepts. They have their own little tweaks. But we also have, where am I here? Network. Terraform doesn't just stand up your servers and your disks and your autoscalers and stuff like that. Terraform can also set up your security group rules. So I'm setting up ingress for port 22 for Bastion SSH so that my Bastion host can receive SSH. Terraform can do things like set up our NAT gateways so that our internal servers can reach the outside internet without the outside internet being able to reach back into our internal servers. But it also sets up our subnets, it sets up our networks, it's setting up all of my security and firewalls and networking. It's basically bootstrapping my entire environment for me. So when we set up our security group like this, or when we set up our networking like this, we're just passing in our information here. And you can tell that we're tying resources together because we're using interpolation. And this is one of the features that makes Terraform really powerful. And we'll see this in a minute when we talk about the VPN part of this. But Terraform is able to take the output of one of these resources. So when you stand up when you allocate an IP address, it's able to tell you which IP address it just allocated. And you're able to interpolate it into other resources like this. And so you're able to kind of string together resource definitions based on the other resources that you're using in your Terraform config file. So that's interpolations. If we look at nodes, we see largely the same thing. We've got a launch configuration, which is like an instance template. It's also doing our rewriting for our variables in our config files. We've got an auto-scaling group, which works a lot like an instance group manager. It's also scaling those up. And we're setting up IAM roles for all of these instances so that they can talk to the EC2 server, or the EC2 services on our behalf, so that they can find out about other AWS roles. Because just like with GCP, the AWS cluster is going to bootstrap itself based on this metadata instead of us hard coding IPs in. And if we look at nodes, again, largely the same thing. The most notable part of this demo is how boring all the config files are. because they're all basically like, yeah, you set up a launch configuration and an auto-scaling group, just like you would with any application. And it's very simple to do. So we're defining a bunch of properties on them here, and we're setting roles on them. And it's, again, the same thing. So now we're getting to the interesting part, though. This is where things go a little bit off the rails. We need to make these two clusters talk to each other. And for that, we're going to use a VPN. So if we go back to our diagram, basically, we have the two clusters. We want to join them with VPN tunnels. The VPN tunnels are going to help us communicate within the private networks of each of these clusters without exposing our traffic to the public internet. So Terraform's also going to stand up our VPN connection for us. Literally nothing in here is anything that I need to SSH or point and click for. I get my entire environment from a single Terraform apply command. So if we look at the AWS config for this, you can tell that we are using a customer gateway, a VPN connection route, and you notice that I am bringing in all of these interpolations. This is where Terraform's power really shows, because you can take, for example, the variable that defines the CIDR group, or the CIDR mask for GCP, and you can embed that right in AWS. So there's no more trying to make sure that your configurations all match. They automatically flow the data through where it needs to be. You can look up things like, let's see if I can get a good one here. Where's my tunnel here? My tunnel, oh, nope, that's in GCP. So if we look in GCP, you can tell we are taking the output from the AWS VPN connection, and we're using that as the input parameters to the Google VPN connection, so that we don't have to chase these values down anymore. They just automatically are set to the correct things. And that gets us an entire VPN setup without doing any custom work, without modifying values. And these can change every time I run the command, and that's okay. Like every time I stand up a new environment, it will automatically provision a new gateway for me, and that gateway's ID will flow through the rest of the code without me having to update. And that's really powerful, because then you get the idea of these disposable environments. You can stand up and destroy your environment within 5 minutes, so it no longer becomes a hassle to stand up a copy of production to test on. It no longer becomes a hassle to test your infrastructure changes, because you can spin up a copy of your production infrastructure, apply the changes, and make sure that it all works the way you want it to. So this allows you to treat your infrastructure the same way you would with your code. You can unit test it, you can or you can integration test it. And this allows you to be it allows your code to be very reproducible in a way that's sometimes hard to get when it comes to infrastructure. So let's take a look at that Nomad cluster we've got stood up here. I'm going to actually just pull up Firefox here for a second. And you'll notice if we look in the GCP pane, there's a bunch of my instances all stood up now. I'm going to actually take that Bastion IP. This is something you can do from Terraform, but it requires you to allocate a static IP for it, and I didn't feel like doing that for this demo, so we are cheating a little bit here. You can tell I'm going to actually, let's make sure my SSH agent works. Nothing more fun than typing in front of people. All right, so I'm connecting to my host, and you can tell I'm now inside of my VPC. I can look at my host here, there's nothing there. And if I want to let's grab the private IP of one of my servers here. There, and we're going to set my Nomad header. So this is basically just telling my local Nomad CLI where it can find a Nomad server to talk to. So now if I do Nomad server members, this is the moment of truth. So I am praying to the demo gods. Hooray! So as you can see, we've got 6 Nomad servers available to us. We've got 3 in AWS, spread across 3 different availability zones, and we've got 3 in GCP, spread across 3 availability zones, all in the Europe West region. So because Nomad is a multiple data center aware cluster tool, we can do things like have it in different regions. And regions are Nomad's concept for things that are able to communicate with each other fairly quickly, is basically the best way to say it. So you can tell here that the region, I'm going to actually close this one out so we get a little bit more space. Hey, that worked. Okay, you can tell the region all the way on the right there. We're using AWS EU West 1 in GCP Europe West 1. These are just names that I specified. They're just the regions in each of those clouds prefixed with the cloud. But you can tell that we're using multiple regions here, and Nomad's able to talk to both of them. But it also knows that they are local to each other, so it's going to try and keep work that relies on each other and those close to each other. So let's actually talk about some of that work really quick. We're going to SCP. I've got an example.nomad here. Oops, I'm in the wrong folder. So I'm going to upload my example.nomad file to that server, and we're going to SSH back in again.
You missed the colon.
Oh, I did. Thank you so much. That is very helpful. I would have been very embarrassed in like 3 seconds. We're going to drop that, and we're going to do this one more time. Oh, y'all are so smart. I'm so glad that you are here with me today. So we're going to, one more time for luck. And there, that's a public IP address. That worked out. Hey, okay. So let's do this one more time. That's not right. We want, I'm going to make sure my IP address matches before I SSH in and wonder where my file is. All right, so if we look at example.nomad, we're actually going to move this, and we're going to call it redis.nomad, just so that we can, oops. This is what happens when I type live. Then if we do, so Nomad's got an init command, and init basically just bootstraps a job for us called example.nomad. And just to prove that I'm not doing anything weird here, there's no custom stuff happening, I'm just going to diff Nomad, the one that I'm running versus what Nomad just generated for me. And you can see all I've done is change the data centers that it's targeting. Nomad's able to target data centers based for each job. A job is basically just a placement of work that you want to happen on your servers, and Nomad's going to make sure that happens. Let's actually just take a look really quick at what we're asking it to do. Oops, I don't have nvim on that one. That's right, I've got vim. So basically, I'm defining an example job, telling it which data centers to run in, and that's any of them. It's going to be a service, a lot of documentation. It's going to update, stagger updates 10 seconds, and there's going to be at most one update in parallel. I'm going to create a task group called cache, and task groups are a way of grouping your tasks. So good job, Nomad team, on naming. And I'm going to tell it what to do when it restarts, which is to restart at most 10 times. And it needs disk to run. Cool. So this is basically, this all seems very straightforward. Oh, and it's defining the task, which is actually running the Docker container Redis 3.2 and mapping it to port 6379. So this all seems very straightforward, but what I'm doing is I'm offering constraints. I'm telling the Nomad cluster scheduler what it needs to place this job. And by doing this, I'm able to take advantage of a lot of things. I don't have a demo for you today, unfortunately, of this, but you could do things, for example, like say, I want to place it based on CPU. I want to place it based on disk space. I want to place it based on whether there are other things like it on the host already. Or even things like, hey, which cloud is it in? So you can target things specifically without having to place it on specific machines. Here it's telling us what the CPU, memory, and network needs are of this service, and it's defining a service for it so that we can do health checking on it. We're going to keep scrolling through this file here, and that's about it. So we're actually going to give this a shot. I think I'm going to need to export again. I don't trust myself to copy and paste anymore. So now if I do Nomad server members, you can see I've got 6 there to choose from. And if I do Nomad node status, what the heck? It's only got 9 nodes there, right? It's only reporting the nodes in the region I'm currently in. If we want to report other nodes, we need to tell it which region to use. And I hope I'm using the right command here. This will be very embarrassing otherwise. So we want to get those Nomad, or those AWS nodes. There are those AWS nodes now. So we're able to, from whichever network or whichever cloud we're SSH'd into, we're able to return all of that cluster information. But can we use it? Well, let's find out. We can nomad plan redis.nomad, and it's saying it's successfully allocated. So let's actually look at that allocation status to figure out what it's allocating. So the allocation happens, it doesn't actually run my job yet. It's just telling me where it's going, or it's just finding a space for it to run. So let's see, let's see if I can get my allocation ID here. I don't think I can. I think I have to run it first. Oh, you're right. It is a plan. Y'all are so smart. So let's go ahead, and we're going to run based on this plan. So what I'm doing now is it's actually running my job. So if I look at Nomad status, and for my example job, you can see that it is running, it's created it, and it's running one of my task group here. You can tell that it's got all of my data centers that I can deploy it in. And if I look at Nomad alloc status, there we go, more information about it. And you can see that it's got the allocation running, and we can even tell where it's running. So let's make sure this is actually running where it says it's running. And based on the IP address, it looks like it's running on GCP right now. So we're going to telnet in, and we want 30654. And we're going to set hello world. And we're going to get hello. And we can see we have a functioning Redis server now running on Nomad. But suppose we want to run it on AWS. Oops, this is Telnet. I can't Control-C my way out of here. And we want to quit. All right. So suppose we want to run this on AWS instead of on GCP. Let's stop example. And it's going to kill my job for me. And now let's give this, so again, fingers crossed for me. I'm actually just going to, so I can copy and paste here. We're going to copy my AWS region, because I never put the hyphens in the right place. Oop, I think I put my orders in the wrong, or I put my arguments in the wrong order. Oh, thank you. I'm so glad you are all here to catch my silly mistakes today. This is like pair programming, but like extreme. What are you all doing on Wednesday? Because I've got to write some code. All right, so let's take a look at that. Example. Oh, I've got to remember to supply my region. So because we're communicating across the wide area network right now, we've got to actually supply our region to Nomad to tell it where it's supposed to be doing this stuff so that it can forward commands on to the right servers. So let's take a look at that, and there it is, and there's the alloc ID, and Nomad alloc status, region, and let's see if I can type this out correctly, AWS EU West and 1. All right. All right, and we can tell that, oh, because it's got a 10.0.4, I know this is running in AWS now. So let's give that a telnet and give that a run. And I don't think I opened the ports for that. Whoops. OK, so that does work if you open the security group and firewall ports for it. However, this is a good demonstration that this is actually a locked down and secured network for us to be using. And we cannot even get to it ourselves unless we configure it properly. So that's basically the demo of that for the moment. So let's go back here, and we're going to run our show again. We're going to spread we can spread jobs over at Google and Amazon's cloud, all from our Bastion instance. We can target jobs to a specific cloud. we can handle server failures gracefully. I didn't demo it, but if I delete one of those servers, the instance group manager spins it right back up because it's told I want 3 servers. We can handle data center failures gracefully. We can delete all of the servers in an entire availability zone, and because we're using instance group managers, they will all spin right back up, and Nomad will have them all rejoin immediately, and it all works out really nicely. And we can even handle cloud failures gracefully. We can sever the entire VPN, and both clouds will keep on trucking. The way Nomad does this is it doesn't use the wide area network for strong consistency. It uses it for gossip to tell all of the other servers about each other, but doesn't need them to agree on anything. So, takeaways, really quick. Multi-cloud is attainable today. This is something you can do. This isn't difficult. This isn't going to be impossible or a headache. It can work. It can have a nice workflow. It could be expensive. It could be more complex. But depending on what your needs are, that may be worth it for you. And agnostic tooling should be the foundation of any multi-cloud strategy. This all works because all of these tools don't really care where you're running your software. They're for any application, and they're on any infrastructure. And that's all I have for you. Thank you so much for your time today.